Unit 2, Activity 6, Solving Exponential and Logarithmic Equations. So far, we have used tables and graphs to solve exponential equations. In this activity, we will learn an algebraic method for solving many exponential equations so that we do not have to depend on technology. The method, called logarithms, uses a new type of notation. Similarly to when we first learned function notation, you will need to accustom to this new notation in order to effectively understand and use logarithms. Learning outcomes, you will explain why radicals, exponents, and logs have certain values. You will also find function values using radical, exponential, and logarithmic representations. And also technology will be used to compute radicals, exponentials, and logarithms. You will also convert between radical, exponential, and logarithmic representations. You will learn methods for solving exponential and logarithmic equations. Let's start with some warm-up problems. Simplify each of the following radical expressions using your knowledge of exponents. Note that you may also be able to check your answer using technology. Just look for the symbol x root of. Alright, let's start with square root of 16. That is equal to 4. Cube root of 8 is 2. Cube root of negative 8 is negative 2. Fourth root of 16 is 2. Fourth root of 81 is 3. Fifth root of 32 is 2. And sixth root of a million is equal to 6. Then number 2, explain why cube root of negative 125 is equal to negative 5. Because cube root of negative 125, we can rewrite this as negative 125 raised to 1/3. And negative 125 is the same thing as negative 5 cubed raised to 1/3. That is because 5 times 5 times 5 is equal to 125. And now there's the same thing as 3 times 1/3 is 3 over 3 is equal to 1. So that's why the answer is negative 5. Okay, so same thing with all of these examples here, like square root of 16. That is because 4 times 4 is 16. Cube root of 8, that is 2 times 2 times 2 is positive 8. For cube root of negative 8, that is negative 2 times negative 2 times negative 2 is negative 8. Same thing with fourth root of 16. 2 times 2 times 2 times 2 is 16. That's 4 times. Multiply 3 4 times 3 times 3 times 3 times 3 is 81. This is 5 times is 32, and 6 times 10 times 10 times 10 times 10 is equal to sorry, this is 10, because 10 to the 6 is equal to a million. Sorry about that. Alright, so let's start with our class discussion. To summarize how we think about radical expressions, mathematicians use the equivalency nth root of b is equal to b. You can rewrite that as b to the power of n is equal to p. For example, cube root of 8 is equal to 2. You can rewrite that as 2 cubed is equal to 8. So one of our learning objectives in this activity is to learn a new equivalency to these two expressions, and we call this as logarithmic form. So from this, nth root of p is equal to b. To write it as in this radical form, b exponential form, b to the power of n is equal to p. Now to logarithmic form, log base of b of p is equal to n. So let's have an example here. Again, cube root of 8 is equal to 2. In exponential form, that is 2 cubed is equal to 8. And we can rewrite this in logarithmic form, that is log base 2 of 8 is equal to 3. Okay, let's have some practice here. Complete the missing equivalent parts of each of the following expressions. Cube root of 64 is equal to 4, and that's the same thing as 4 cubed is equal to 64, because 4 times 4 times 4 is equal to 64. And we write this to logarithmic form, so that is log of the base of the exponential is 4, so the base is also 4 here, of 64 is equal to 3. Letter B, fifth root of 32 is equal to 2. Then we can rewrite this as, yes, 2 to the 5th is equal to 32. And in logarithmic form, yes, this is going to be log base 2 of 32 is equal to 5. Letter C, fourth root of 81 is equal to 3. So we can rewrite this as 3 to the power of 4 is equal to 81. 3 times 3 times 3 times 3 is 81. And the log form, log base 3 of 81 is equal to 4. Letter D, we only have here 6 cubed is equal to 216. So we can say that cube root of 216 is equal to 6. And we can write into log form, log base 6 of 216 is equal to 3. Letter E, we only have here log base 2 of x is equal to 8. You can rewrite this as exponential, that is 2 to the power of 8 is equal to x. And now we can rewrite this as eighth root of x is equal to 2. Yep. How about letter F? 7 to the power of x is equal to 100. Then this is gonna be, yes, x root of 100 is equal to 7. And this is going to be log of base 7 of 100 is equal to x. Okay, please try this, all of these problems. Number 2, find the value of x in which the following log equations by rewriting the equation in exponential form using your knowledge of exponents. Do not use technology to solve these problems. Alright, letter A, log base 3 of 9 is equal to x. So we're writing this in exponential form. The easiest way to do this is you do this. That's going to be 3 to the power of x is equal to 9. And we know that 9 is 3 squared. Now they have the same base of 3, so that x is equal to 2. Letter B, log base 2 of 16 is equal to x. Let's do this. So you can rewrite this at 2 to the power of x is equal to 16. And we know that 16 is 2 to the 4th. 2 times 2 times 2 times 2. Now they have the same base of 2. We can use their exponents. So x is equal to 4. Letter C, log base 6 of 36 is equal to x. If we do this, 6 raised to x is equal to 36. 6 raised to what number is equal to 36? Yes, 2, because 6 squared is equal to 2. So x is equal to 2. And letter D, log base 10 of 10 is equal to x. So we can write this as 10x is equal to 10. 10 raised to what number is equal to 10? Yes, the exponent here is 1. So x is equal to 1. Very good. Up until this activity, we use a table or graph to solve exponential equations. We can now solve exponential equations by rewriting them in equivalent logarithmic form using technology to calculate a decimal value. Let's say, for example, 2 to the power of x is equal to 15. You can rewrite this expression in equivalent logarithmic form. That is, log base 2 of 15 is equal to x. So from here to here. And you can use technology to get that value of x. So all you have to do is just type this, log base 2 of 15, and you will get x is equal to 3.9069. This is how to use Desmos to solve that log base 2 of 15. So you just have to type log base 2, meaning underscore 2 of 15, and you will see the answer is 3.9069. Easy, right? To show how we can check that x is equal to 3.9069 is really the solution to the equation 2 to the power of x is equal to 15. So substitute the value of x, 2 raised to 3.9069 is it equal to 15. Let's use Desmos again. So 2 raised to 3.9069 is equal to 15. So meaning that is correct. Okay. More examples here. Number 3. Solve the following exponential equations using equivalent logarithmic form. Letter A, 3 to the power of x equal to 10. The base of the exponential is 3. So that's going to be the base of your log. So log base 3 of 10 is equal to x. And we're going to use Desmos later to find the value of x. Letter B, 0.1 is equal to 0.5x. The exponential, the base is 0.5. Like this one, the base here is 3. So to write in log form, that base is going to be your base of the log. Log base 0.5 of 0.1 is equal to x. Okay, now let's go to Desmos to get the answers. The first one, letter A, log underscore 3 of 10 is equal to 2.0959. And letter B, log base, so just press underscore, of 0.5 of 0.10.1 is equal to 3.3219. So check your answer, like the first one, 3 to the power of 2.0959 is equal to 9.9999. If we round off, that is equal to 10. The second one, 0.5 raised to 3.3219 is equal to 0.1. So those two are correct. And yes, we did check our answers. We got x equal to 2.0959 and 3.3219. Okay. Next set of problems. Number 4. Solve the following exponential equations by first simplifying and then using the equivalent logarithmic form. You should pay attention here because you will see these type of problems in your quiz next week. Letter A. 4 times 2 to the power of x equal to 20. First, we need to simplify it. That is by dividing both sides by 4. So that this is now 2 to the power of x is equal to 20. And now we can rewrite this into log form, the equivalent log form. So that is, remember the base is 2. So the base of your log is also 2. Log base 2 of 20 is equal to x. Use decimals, x is going to be equal to 4.3219. Next, letter B. 10 is equal to 5 to the power of x minus 2. First simplify, so we add 2 both sides. So that is 12 is equal to 5 to the power of x. Then rewrite this to log. Base is 5, so log base 5 of 12 is equal to x. And using technology, x is equal to 1.543 or 40. Letter C. 25 times 1.35x plus 50 is equal to 200. So to isolate the exponential, first we subtract 50 both sides. (200 minus 50 is 150), and then divide both sides by 25. So that is now 1.35. The power of x is equal to 150 divided by 25 is 6. Then now we can rewrite this to log. So that is log of 1.35. Log base 1.35 of 6 is equal to x. And x is equal to 5.9705. Okay. Then letter D. 240 times 0.5 to the power of x over 4 minus 1 is equal to 8. So first, add 1 both sides. So that is 240 of 0.5. The power of x over 4 is equal to 8 plus 1 is 9. and then divide both sides by 240. So that is 0.5. Remember our topic last activity with a fractional exponent. You can rewrite this as 0.5 to the power of 1/4 raised to x is equal to 9 over 240. 0.5 raised to 1/4 is like 0.84089 or 8409 to the power of x, and 9 over 240 is 0.0375. So now we write this into log form. Our base is 0.8409, so we can write that as log base of 0.8409 of 0.0375 is equal to x. Now use technology to solve for x, and x is equal to 18.9483. Take note of this. Many devices will have log base b of p function, but some will not. If you do not have this function, use one of the following formulas with either the log function or the ln function. So we call this as change of base formula. So whenever you solve this with a calculator, you can rewrite this as log base of p, log p over log of b, or ln of p over ln of p. Just like this, our last example, you can solve this log base of 8409 or 0.0375. You can rewrite this as log of 0.0375 over the log of 0.8409, and you will get the same answer of 18.9483. Okay, so we call that as the change of base formula. Next, alternately, we can solve logarithmic equations by rewriting them back into exponential form and then using technology to calculate the precise result. For example, here, log base 4 of x is equal to 5. What we did earlier, you can rewrite this into exponential. That is 4 to the 5th is equal to x. So using these arrows, 4 to the 5th power is equal to x, and using technology, 4 to the 5th is equal to 1024. So how we can check that x is equal to 1024 is really the solution to the equation log base 4 of x is equal to 5. So when we substitute log base 4 of 1024, is that equal to 5? Using these arrows, I'm going to write it here. I have a space here. Is 4 to the 5th equals 1024. And 4 times 4 times 4 times 4 times 4 is equal to 1024. So that is correct. Number 3, solve the following logarithmic equations using the equivalent exponential form. So again, we can rewrite this. 3 to the power of 6 is equal to x. And 3 to the power of 6 is 729. Letter B, 1.5 is equal to log base 1.25 of x. So rewrite this into exponential. So that's going to be 1.25 to the power of 1.5 is equal to x. Then use your calculator. 1.25 raised to 1.5, x is equal to 1.3975. Okay, and you can check your answers. Okay, the last part. Solve the following logarithmic equations by first simplifying and then using the equivalent exponential form. Letter A, 5 plus log base 2 of x is equal to 20. First, we subtract 5. We isolate the logs. So log base 2 of x is equal to 20 minus 5 is 15. And then let's use the arrows. 2 to the power of 15 is equal to x. 2 to the power of 15, that is 32,768. Letter B, log base 2.5 of x over 3 is equal to 2. If we multiply both sides by 3, so 3 times 2 is 6. And then use the arrows. 2.5 raised to 6 is equal to x. Calculator. 2.5 raised to 6 is equal to 244.14. Letter C. 8 times log base 0.5 of x minus 2 is equal to 20. First, we add 2. (20 plus 2 is 22). Then divide both sides by 8. To divide by 8 is 2.75. Then we write this into exponential. That is 0.5 raised to 2.75 is equal to x. Use your technology. 0.5 raised to 2.75, x is equal to 0.1487. And letter D, if you subtract 7, 1.5 log base 6 of 2x is equal to -3, and divide both sides by 1.5, so that is log base 6 of 2x is equal to 3 over 1.5 is -2. Then let's write this into exponential. So 6 the power of -2 is equal to 2x, and then divide both sides by 2 to get the value of x. And when you use your calculator, 6 to the power of -2 divided by 2 is 0.0139. Okay, so please try all this, and that's it for activity 6. And if you have any questions, please let me know. Okay, thank you.